All right, today we're going to focus on two-step linear equations. I know we introduced this last class, but today we're going to hopefully start mastering this concept and understanding exactly what we have to do to get x all by itself. So we're going to start with a recap of one-step and two-step linear equations. We'll also look at word problems for two-step linear equations. We looked at word problems for one-step equations yesterday, so it'll be interesting to see what two-step linear equation word problems look like. Then we're going to look at a new type of two-step linear equation because after all, there isn't just one kind, right? We only learned one kind yesterday, but the main idea is still going to be the same. To solve a linear equation, regardless of whether it's one step or two-step or whatever kind of two-step it is, to solve a linear equation, you just use reverse BEDMAS in order to undo everything that is happening to the x. You just have to hit one piece at a time. So if we follow reverse BEDMAS, that means the first piece you're going to hit is the addition subtraction, then you're going to hit division multiplication, then exponent, and then brackets. Anyway, we'll worry about that when we get to it. Here we go. So for one-step equations, I want us to get a little bit of review on this one. So I'm going to ask that you please just pause the video here, get out a piece of loose leaf paper, give these two questions a quick try, and I'll go over them in just a moment. All right, so I'm going to go over these now. First one, 5 over 3 times x equals 10. So since this is 5/3 times x, we can just get rid of this by dividing by 5/3 on both sides. But here's where something kind of funny happens. If we're going 10 divided by 5/3, this is where we have something divided by a fraction. As a matter of fact, you could probably think of this as 10 over 1 divided by a fraction because any number on its own can be written as a fraction over 1. So since this is a fraction divided by a fraction, we have to use keep, change, flip. So first of all, x equals, keep the first one alone, so 10 over 1, change from a divide to a times, flip the fraction that's actually doing the dividing. So this is going to become 3 over 5. This is going to become 10 times 3 over 1 times 5. So in other words, x equals 10 times 3 is 30 over 1 times 5 is 5. So x is 30 over 5, but this actually simplifies down really nice because 30 divides by 5. 30 divided by 5 is, of course, 6. So in other words, 6 is going to be our solution for that first problem. Next question is very similar, -7 over 4 times x. Once again, you can divide by -7 over 4. But I'm actually going to show you another little trick here. If you prefer to do it this way that we've been doing so far, by all means, keep going to it. But personally, when I see something with a fraction in here, just like the last one, I actually break this down a little bit differently. Notice it's -7 divided by 4 times x. We could actually get rid of this, just the divide by 4 part, by timesing by 4 on both sides first. So if we times by 4, that gets rid of this right here, and this is going to leave us with -7x equals 8 times 4, which is 32. Then we divide by -7, and you're going to find that x is going to equal -32 over 7. The negative, of course, was attached to the 7, but it can always go up to the top. I usually put it on the top just for good measure. But x is -32 over 7. So using that little newfangled way, I just kind of broke it down one piece at a time rather than hitting the whole fraction all at once. But if you prefer to do the whole fraction all at once, I can show you. -7 over 4x equals 8. It works the exact same way, just divide by -7 over 4, which means we've got divide by -7 over 4. That gets rid of this guy completely over here. So this gives us x equals, we're dividing by a fraction here, so we got to keep, change, flip. What do you know? 8 times 4 is 32. 1 times -7 is -7, but we put the negative on the top. What do you know? It gave us the exact same answer. So personally, I like getting rid of the denominator here first and then dividing away the numerator. So it's like I do the same thing where I times by 4 and divide by 7. I just do it in a little bit of a different order. So whatever floats your boat on this one, if you want to do it one way or the other, but just know that there's other ways of solving these problems. All right, here's a couple examples of two-step equations. Once again, I want you to pause the video here and give this one a try. All right, I'm going to go over this one. First one is a pretty quick two-step equation. We just need a times by x on both sides. This is going to give us 9 equals 2x. And then we need to divide by 2 on both sides to get x equals 9 over 2. Or if you're more of a fractions person, 9 divided by 2, or sorry, more of a decimal person, 9 divided by 2 is 4.5. So either way you slice and dice this, it's totally correct. You can leave it as a fraction, you can leave it as a decimal. I do not care. Next one, -14x minus 5 equals 93. These are like the ones we introduced last class. This is where reverse BEDMAS becomes really important. We need to get rid of this minus 5 that's happening to the x first. So let's add 5 on both sides. This will give us negative 14x equals 93 plus 5, which is 98. And then we need to divide by negative 14 on both sides. So this will leave us with x equals 98 divided by negative 14. I'm pretty sure that that's going to give us negative 7 as our answer, because a positive divided by a negative is going to be a negative. Anyway, moving on. So here's a word problem involving two-step linear equations. Always with word problems, we always have to generate the linear equation on our own. So it's important to take a look at what you've got and what kind of relations you might be able to create from that. So it costs $30 to rent a kayak plus a cost of $5 per hour. When Emily went kayaking, it cost her $55. So that would be her total cost, in other words. With x representing the number of hours, write an equation representing this. So here's where we break this down. Look for a word like per, right? $5 per hour. That means for every hour you're putting in here, and hours are going to be represented by x, you have to times by $5 for each one of those hours, right? So we can say 5 times x is going to represent our hourly cost for x number of hours. So if x was 4, like if you went for 4 hours, it'd be 5 times 4, so it'd be 20 bucks. But regardless of that, we also have to add $30 to this because it's $30 to rent the kayak plus $5 per hour. So we'll say plus that $30. Notice 30 is not connected to an x or any other variable because it's a flat fee. It just stays there on its own the whole time by itself. So 5x, so 5 times x number of hours plus $30 is going to equal $55. So this is the linear equation that would represent that situation. Next part of the question, how many hours did she rent the kayak for? So in other words, we've got to solve for x given that this total cost was $55. To solve for x, we need a minus 30 from both sides because reverse BEDMAS would say get rid of the addition first. This leaves us with 5x equals 55 minus 30, which is 25. And then we need to divide by 5 on both sides. And this will leave us with x equals 25 divided by 5, which is 5 hours. Perfect. All right, moving on. Next word problem. Mason works 5 days a week and gets paid the same amount each day. This week, he received a $40 bonus on his paycheck. His paycheck was $750. How much did he get paid each day? So let's try to break this down. He gets paid the same amount each day, and he works 5 days a week, right? His weekly paycheck here was $750, but he did receive a $40 bonus on it. Now that $40 bonus is sounding like a one-time thing. In other words, it's not attached to how many days he worked. So since we're looking for how much he was paid each day, let's break this down into being 5 days a week times whatever he gets paid each day. So X is how much he's being paid each day. That's what we're looking for here. Plus that $40 bonus that he received is going to equal $750. Let me break this down for you once again. 5 times how much he gets paid per day, because he's getting paid the same amount each day, 5 times his daily pay, plus $40 bonus equals $750. So if we're going to rearrange this and solve for x now, let's see if we can get this. Minus 40 from both sides. So from this side of the equation and this side of the equation, minus $40. This is going to give us 5x equals 750 minus 40, which is 710. Then, of course, we want to discover what x is equal to, so we got to divide by 5. This is going to give us x equals, and I got to get my calculator out here, 710 divided by 5. That's going to be $142 per day. I don't require you guys to give a sentence in your response. It is nice. So if you wanted to write Mason makes $142 per day, by all means go for it. But I don't necessarily look for that as long as you have your answer very clear. In this case, I've boxed my answer. That is all I really care to see. All right, next up, we have a new type of two-step linear equation to solve. It's x over a plus b equals c type equations. Really, although this is a new type of linear equation, really it's the same idea. We just have to still use reverse BEDMAS to solve by undoing whatever is happening to the x. Okay, so let's have a look at this first example. X over 2 plus 4 equals 15. we want to get x all by itself, we need to use reverse BEDMAS. So let's start by getting rid of any addition or subtraction. So let's minus 4 from both sides to get rid of that plus 4, right? This is going to give us x over 2 equals 15 minus 4, which is 11. Last but not least, we want to get x by itself, so let's times by 2 on both sides. That gets rid of the divide by 2. And this leaves us with x equals 11 times 2, which is 22. So really not all that much different. You know, these are pretty much the exact same things what we did before. Next question, x over 5 minus negative 5 equals 20. Now this right here, minus negative 5, I hate that. Cannot stand when I see like a double negative kind of thing here. Drives me up the wall. What I want you to remember is when you have a minus and negative 5, that's the same thing as saying plus a positive 5. Okay, that makes your life a little bit easier here. So we got plus positive 5 equals 20. Undo whatever you got going on here. So let's minus 5 from both sides. And that's going to leave us with x over 5 equals 20 minus 5, which is 15. Then, of course, we want to get x by itself by timesing by 5 on both sides. So x equals 5 times 15. I'll say that's going to be 75 as your answer. So again, it's not really any different than what we've dealt with before. It's just a matter of picking it apart one piece at a time using reverse BEDMAS. So it's time for you guys to get a little bit of practice with this one. Just try these two questions on this page here. Just pause the video here, write them down, give them an honest shot, and then compare to see whether you got the answer right. All right, I'm going over these ones now. First things first, using reverse BEDMAS, let's add 9 on both sides here. That's going to give me x over 4 equals 2 plus 9, which is 11. Then we need to multiply by 4 on both sides. Yoink, yoink, and that's going to give us x equals 11 times 4, which is 44. Perfect. Next one down here, similar idea, x over negative 5 plus 6 equals 14. Get rid of your addition or subtraction first. So we have plus 6, we just got a minus 6 on both sides. This is going to give us x over negative 5 equals 14 minus 6, which is 8. Then we need to get rid of this divide by negative 5 by timesing negative 5 on both sides. That's going to leave us with x equals 8 times negative 5 is negative 40. So always watch when you have a positive times a negative, it switches it down to a negative answer. One last example, this one has fractions in it, and you know what, just for fun, I want to see if you guys can try this one as well. Give it an honest shot. This is how you're going to learn from it. See if you can get this one on your own. All right, I'm going to try this one now. First things first, you're going to see that it's x over 2 minus 3 over 4 equals 10 over 8. So you're going to want to get rid of this minus 3 over 4 first by adding 3 over 4 on both sides. So adding 3 over 4 on both sides is going to knock it out right here. But we have a little bit of an issue on the right-hand side. 10 over 8 plus 3 over 4. You can't add fractions together unless they have a common denominator. So you have to ask yourself, how can I make these have a common denominator? Several different ways of doing this. Personally, what I think I'm going to do is I'm going to switch 3 over 4 into something over 8. Notice I can multiply both the bottom and the top by 2 to turn this into 6 over 8, which is the same thing as 3 over 4. It's just written with 8 as a denominator. So if I multiply the top and the bottom by some number, you can keep it to be the same value, just, you know, with a different denominator. So this will make it a little easier to solve now. We have x over 2 equals 10 over 8 plus 6 over 8. Remember, when you add fractions, you just add the numerators. 10 plus 6 is 16 over 8. Couple different options you can do here. Again, we're only one step away from solving what x is, because really you just have to times by 2 on both sides to get x all by itself. But before I do that, I want you to notice 16 divided by 8, that's actually just 2. So in other words, I can change this before I go any further by saying it's x over 2 equals 16 divided by 8, which just equals 2. Now that it's like this, this becomes an even simpler problem, right? So now I can just times by 2 on both sides to get rid of this divide by 2. And you're going to see that x is equal to 2 times 2, which is 4. So x equals 4 would be the solution to this one. Now, if you didn't want to go this route where you went like 16 divided by 8 to get 2, you could have just multiplied by 2 on both sides right here. And what that would have done is it would have given you x equals 16 over 8 times 2. That's technically times 2 over 1. It's going to give you 32 over 8. And then likewise with 32 over 8, you could actually see that 32 divides by 8. So you could say x is equal to 32 divided by 8, which is 4. So either way you do it, however you slice and dice this, you still get the exact same answer one way or another. Math is a little flexible. You can actually kind of do whatever you want it to do as long as you're following the correct rules and the correct order of operations. So for practice today, I want you to try page 311, questions 7 to 15, and then 17 to 20. You are not obligated to finish these today. Just work on them. We will have some more time a little bit later to continue working on these, so don't feel like you're pressured to get them all done. If you do get them all done by the end of this lesson, I think this lesson is scheduled for, I think it's scheduled for Thursday, maybe it's Wednesday, I can't even remember. I'm just recording these as I go. I'm pretty sure it's Thursday that this is scheduled for, but if you don't get them done by the end of the day, don't sweat it, don't worry about it. You might have already started questions 7 and 8 from last class. Anyway, do what you can, right? Check your answers at the back of the book. Come back to our Zoom meeting. Ask me for any questions if you need. I'm here to help. Best of luck.